Let's print.
Hey, it's Joel. I'm at Virginia Tech, and we're going to be 3D printing with hybrid robotics. Is that right, Isaac?
Yes.
Good to see you, man.
Good to see you.
Hybrid robotics. When I think about that, I think of robotics, but in situations they weren't before. Is that correct?
Yeah, kind of. Hybrid really refers to when you're combining multiple manufacturing techniques in one environment. And so in our case, what we're going to be doing is we have the robot printing with DED arc, so a wire arc process. And then we're using it in collaboration with the CNC you see behind us, and that will do the machining afterward.
Okay, looking at this setup, we've got a robotic arm,
yes,
a DED end,
yep,
and it's 3D printing inside of the CNC machine.
Yes. What? Standalone hybrid additive machine, they do exist on the market, and they'll have both a machining spindle and a torch in one machine. A big limitation of that is those machines are pretty expensive.
How much?
Oh my gosh, they can be upwards of like $250,000 per machine.
Really expensive?
Really expensive.
Okay.
If you are a shop owner and you want to get into hybrid manufacturing and you want to extend the capabilities of your shop, that can be a really difficult purchase for just one. Never mind, you want your whole factory floor to be, you know, switched over to hybrid.
Oh, I see where you're going. Okay.
So the idea with this is you see the robot, but the robot's actually on wheels. And so can we bring the robot in? Print when we need to, and then when we're done printing, we can roll it out and move it to a different machine. And so you buy one robot, and now your entire floor is all hybrid.
Oh, so this Tormach, there's nothing special about it. It's just a Tormach CNC.
It's just a Tormach.
CNCs like this are all over the world, like in machine shops all over the world. Buy a robot, use what you have rather than robot for a new thing.
Yes, or having to buy a whole new machine, right?
Yeah.
Yeah.
Oh, because the investment in these is
a lot.
A lot.
Yeah.
And so if you can use what you have, oh, you save money and you get to do cool stuff.
You get to do cool stuff, and it's really scalability is the name of the game here.
As far as the robotic arm goes, there's nothing, also nothing special about this one, correct?
Nope. So we're using, it's just an ABB robotic arm that we bought. The welding unit is a Fronius CMT Advanced, also just off the shelf. The only sort of custom work that we've done is we added the controls to get the two to talk to each other, as well as, it's not on right now, but in order to get the robot and the CNC machine to agree on where everything is in space so that they, you know, where I print is where I go machine later, I need to take a picture of inside the CNC and use that to figure out where everything is.
Oh, so robot's got a camera.
The robot's got a camera, but it's off right now while we're welding.
Okay. Oh, so the robot can tell the CNC to like move?
Kind of. So we actually, we kind of do it the other way around. So we move the CNC to a place where it's convenient for the robot to reach. And then we say, okay, we know where everything in the CNC is, and we send that information to the robot, and the robot will update its tool path to match where things are with the CNC.
Oh, because I see the QR codes all over the CNC machine, and so that's going to tell the robot kind of where things are in 3D space?
Exactly.
This is cool, Isaac! Like,
it is really cool. Yeah.
So cool. We could print, right? This is set up to print.
It's set up to print.
Well, then I'm going to get out of your way.
Okay.
Like, what? Wait, to print though, this is welding. This is DED.
Is welding. I have some helmets for us.
There we go. Will it fit my big head?
Should. It's adjustable.
Adjust it way up.
Let's print.
Next step is milling, I would imagine, right?
Yes. So because DED is a near net process, in order to meet part tolerances for any sort of critical application, you have to post-machine once you're done printing.
Oh, well, yeah. I mean, you've got a little bit of extra, right? You just kind of have to take it off.
So a great benefit of a hybrid machine is I don't have to pick my part up out of wherever I printed it and move it and re-indicate it in the new machine. Oh. So it's all print in place, right?
Right. Okay. Oh, yeah. In a configuration where you would have to remove it, you would have to rehome and do all sorts of crazy things to make sure that it knew where it was before you started milling away.
Exactly.
Okay.
So now that the robot has done its job and the part looks great in the machine, we can go ahead and just mill with sort of the normal post-processing.
We are just going to use the Tormach to do Tormach things.
Exactly.
Oh, heck yeah. Okay. Do we need safety glasses?
Yes. Give you these.
Thank you.
Sorry.
Oh my
we don't
goodness.
have the special over the glasses ones.
I still look cool, right?
Yeah. So It cuts air because we have to be really careful because we don't actually know exactly where the part is.
Yeah. You are starting far off of the part just to make sure you're not like diving the tool in.
Exactly.
Okay.
Exactly.
Okay.
So
that's fair, right?
yeah. So the bead is really inconsistent, which is really bad for machining. Is you want a nice surface, a well-known surface. So it's actually going to once it starts machining, it'll like cut the outer edges of the bead where it's like slightly wider before it gets into the true surface.
Well, like if you think about if you're turning a shape on a lathe and it's irregular, you have to take care of the irregularities first, right? So is this kind of the same concept?
Yes.
Oh, good things take time, Isaac.
Yeah. So some of the other work in the lab is how do you know exactly where the part is so you don't have to spend all this time cutting air. But this is a simple path instead. So
it's just fascinating to watch it right now because I know it's cutting air technically, but like at some point it's not, and I'm gonna get to see it. It looks like the milling operation is done, and we'll be able to take out the part. But before we do, people are going to be curious. How did you grow up knowing you wanted to like do hybrid robotics? Like as a 6-year-old, were you dreaming of robots?
Yeah, I mean, I guess I was always interested in STEM, and then I actually in middle school I got the chance to build my own 3D printer with the RepRap project.
Cool.
Yeah, so I've been doing 3D printing for a while, and then I came here and I was able to do undergraduate research starting freshman year. They brought me in and they're like, we have the robot, go get the tool working. And I've been here ever since. I loved it so much. I stayed for my master's, and it's definitely opened doors. I had no idea this type of printing existed until I got here, and it's awesome and I love doing it.
It's really cool that you came from the RepRap project and essentially you came here and they were like, here's a problem, solve it.
Exactly.
Word to your mother.
Well, our problem has been solved.
Exactly.
And it's time to get it out. Wait, before we do, can I?
Yeah.
Yeah, okay. Okay, we're in a safe space now.
Yeah.
No more machine running.
It's not spinning anymore.
Yeah. In the milling operation, it's not completely nice, fresh, smooth, but this was, I know it's a demonstration, but it's a demonstration of how we can go from near net to spec, right?
Exactly.
Cool.
Yeah. So like you'll notice when you see it in the metal, it's completely solid. So if it were to get fully machined down to like to spec, it would look nice and shiny and indistinguishable from a traditionally made part.
Well, next step is take it off, right?
Exactly.
See, build plates in CNC are different. Like a 3D printer build plate at home on the farm, I just go and the part comes off. This one, you have to use tools. You got this, come on.
When you print, the plate heats up and expands.
Oh, thermal expansion.
Exactly.
Oh.
And so it can actually cause some of the stuff to seize when it cools back down.
Or hold really well.
Hold really well.
Hold really well, yeah. Oh, look at that.
Whoop.
Well, thank you for me.
Yeah.
I'll have to put in my truck luggage.
Well, hold on.
Oh, cool. So you can see some of the chips that are inside.
Yeah.
But I mean, if you take a look at the outside, you can see the near net shape. So that's cool. I remember you talked about how this is a more efficient process.
Yes.
And you can really tell because having to essentially hog this out of a solid piece produces a lot of chips and a lot of potential waste, whereas this seems really minimal.
Yeah, it's a lot more material efficient, and there's all sorts of other benefits of hybrid. You could actually pause your printing, machine in the middle, and then keep printing to allow you to sort of get weird geometries that you wouldn't traditionally be able to machine. So there's all sorts of fun tricks you can play with it, sort of.
This is fun, Isaac. I really love this because it's utilizing a tool that is ubiquitous in machine shops just throughout the world. And you're bolting on a robotic arm to give it more functionality.
Exactly, extending the capabilities of already existing CNC machines.
Hybrid robotics.
Hybrid robotics.
I love it. All right, well, Isaac, everybody out there is going to be really curious as to where they can learn more about what you're doing here. And so look in the camera and tell everybody where they can go to find out more.
This is all part of the Virginia Tech Made Center. There should be a web page. You should be able to find more information about stuff there.
That web page we'll find and we'll put it in the description.
Thank you.
Thanks for watching. If you made this far, you're awesome. Don't forget to hug each other more. Fight for a cause you believe in. Print and machine all the things like this. And as always, high five.
There we go.
Crisp.